Hey, my name is Linda, and this is my robot Pumpkin. Halloween is coming up soon, and Pumpkin decided to be E. coli this year. So today, Pumpkin will be modeling the bacterial chemotaxis behavior. Chemotaxis allows flagellated bacteria, such as E. coli, swim towards or away from stimuli in its environment. In this video, bacteria are attracted to a sugar crystal. They use a run and tumble method, in which the bacteria will embark on a run and swim forward in one direction, or it will tumble and then move off in a new direction. When the concentration of food in the environment increases, the frequency of tumbling decreases, and when the concentration of food decreases, the frequency of tumbling increases. In short, if a cell realizes it is getting closer to food, it will tend to go on runs, and if not, it will tumble and change directions. Here's a summary of how I coded the behavior. For the main loop, the robot will first gather the ambient light level. Then it will begin running the first behavior called toward light, where light is an attractant. When the user button is pressed, it will break out of the toward light behavior and enter the away light behavior, which I will show later. For the light gathering and tumbling behaviors, I based my code off the ideas of schema theory. For my perceptual schema, I implemented the top function named current light, which gathers data from all three light sensors and calculates the average. For the motor schema, I wrote the bottom function named tumble, which allows the robot to tumble for a random amount of time between 250 and 1000 milliseconds. I also tried to model my code using ideas from subsumption architecture. The top level of code focuses on tumbling and searching for the light source. When the current light level in front of the robot is not significantly higher than the ambient light level, this behavior will take precedence. The next level lower focuses on keeping the robot by the light source if it has already found the light. The code is very similar as for level 2. However, the cooldown time between tumbles is much shorter in order for the robot to stay close to the light. The final layer simply tells the robot to run forward. This behavior only occurs once level 2 and level 1 are completed, aka when the robot has found the light source and is currently in an area close to the light. Here's another take of the same behavior. To make the behavior more lifelike and robust, I included some ideas from BEE 3600, namely exact adaptation and fold change detection. When a new food source is added to the environment, exact adaptation helps bacteria adjust to the new steady-state concentration of food, and the tumbling behavior will eventually return to the same level as before the new source was added. To model this behavior, I wrote a function named getAmbientLight that will collect the ambient light data every time the robot is powered on, and this information is used to decide what the threshold for triggering the tumbling behavior is. Bacterial chemotaxis also relies on fold change detection, where it will sense relative changes in concentration rather than absolute changes. Therefore, in my code, certain behaviors will trigger if the change in light level is large enough to surpass a threshold, rather than it being based off of absolute change in light level. Behavior 2 is coded nearly the same way as behavior 1, except light is now a repellent rather than attractant.